Welcome to Space Station Live, a special report from TUTV, Temple University Television, produced in association with NASA, the National Aeronautics and Space Administration. I'm Nick Lucier.
And I'm Karina Cheung. Let's go live to the Destiny Lab module of the International Space Station, which is orbiting about 260 miles over the Indian Ocean just south of Australia at about 17,100 miles per hour, to speak with 3 of the crew members serving on Expedition 38. We are honored to speak with American astronauts Rick Mastracchio and Mike Hopkins, and from Japan, astronaut Koichi Wakata. How are you, gentlemen?
Yeah, we're doing great. Welcome to the International Space Station.
Great, thank you. So here is our first question.
Hi, my name is Mark Halberstadt, and this is a question for Rick. What is one skill that you didn't think that you would be using on the space station, but once on board has proven to be valuable?
Well, since I had been here several times to the International Space Station, I kind of knew what to expect. But I tell you, one of the things I'm doing a lot more of than I do normally on the ground is a lot more cleaning and vacuuming and things like that. It's definitely a useful skill to have up there because, you know, we have to maintain the space station ourselves. Comes up here and cleans for us. Nobody comes up here and vacuums and wipes the walls. So it's no matter where you go, you still got to do the basic things like that.
I guess this question's for Mike. What is one mistake which was made, and how long did it take to correct on the space station? How long would it have taken to fix the problem had the problem occurred on Earth?
Okay, you know, mistakes. I guess we make mistakes every day just in the execution of our duties up here when we're running procedures and stuff. But very fortunately, we have a team on the ground that's watching over our shoulder, that's following along with us, and more often than not, they catch the mistakes really before they have a chance to develop into anything. And so I'm happy to say there hasn't been any real major mistakes that have been made on procedures up here, but there's been little mistakes, but again, the ground has caught us and helped us out. In terms of failures, of course, we had a big failure last December with one of the cooling systems outside, and that took 3 weeks before we were able to get it fixed by planning and executing a couple of spacewalks. So on the ground, that certainly would have been quite a bit easier, and I suspect we would have had it fixed within a few days.
Hi, my name is Zach. This question is for Koichi. What is your favorite experiment and why?
Yeah, first of all, I enjoy working on all the science activities on board the space station. Especially, I really enjoy working on hands-on type experiments. We have a variety of experiments, but some of the examples are like a spheres experiment that is for the development of algorithm of the multi-spacecraft and robotics control, and a capillary flow experiment for fluid dynamics experiments. Those are really hands-on experiments. And I really enjoy working with this actual execution of the experiments in a direct contact with the scientists on the ground.
Hi, my name is Kaylee Robertson. My question is for Rick. It has been reported that in 2014, a 3D printer will be sent to the International Space Station. What types of projects will the printer be used on, and what are the challenges of building and implementing a zero-gravity 3D printer?
Yeah, that's a great question. Now, I've read articles about how the 3D printer is coming up, and I've heard about it back at the Johnson Space Center. We haven't been involved in the printer development in any way, but I'm sure that it's had some challenges due to just because we're in a zero-G environment. How it will be used, I'm sure in the beginning it will be more just kind of a test thing where we'll make some small pieces and see how they work out. But I could see this being a very, very useful thing in the future as we move on beyond low Earth orbit, when we don't have cargo ships coming up every few weeks and the ground can't send us spare parts on a regular basis. You know, when we're up here, we're on our own. We have all the tools necessary. We have a lot of spare parts, but there's times where we just run out of spare parts. We just don't have the right parts. So I think a 3D printer is going to prove very useful up here in the International Space Station, but even more useful as we go on to the moon, to asteroids, or even onto Mars.
Mike, how much is having a 3D printer expected to expedite design, experimentation, and research happening on the space station?
Yeah, you know, just to kind of follow with Rick's comment there, I think, first of all, we just need to figure out if it'll even work up here. And then how will it help with experiments and execution and things of that nature. I think a lot of it we're going to be dependent upon the ground, because a lot of that design work that you're talking about to actually execute, I think our ground teams will most likely be doing a lot of that kind of activity, and then we'll just do the execution part, if you will, the actual printing out of the part and then the utilization of it. And so I think it'll certainly help out, but again, I think first we need to just figure out that it'll work up here.
Hi, my name is John Morris. This question is for Koichi. What is the process of getting ready for a spacewalk, both physical and psychological?
Yeah, as a support crew member for a spacewalk that Mike and Rick conducted in December, it was a very challenging experience for me, as I needed to make sure that I can send out those guys to the outer space safely and have them come back to the airlock safely. So I had to go back to the basics, just think through before you take actions and follow the procedure precisely and efficiently. And this is what I forced myself to do as a support crew member of a spacewalk.
For Rick, in 2016, the Cold Atom Lab will be installed on the ISS. What is the overarching goal of the Cold Atom Lab, and why is it being installed on the ISS as opposed to an Earthbound facility?
Well, that's a great question. I'm sorry, I'm not familiar with the Cold Atom Lab or that experiment or that research, but it's good news to hear. I enjoy hearing that, the fact that we're going to get new experiments and new research coming up here at the International Space Station. One of the things we find is that there's all kinds of opportunities up here. The space station's an incredible place, can support just about any type of research or experiment going on. And we are involved in many different things right now, but it's always good to hear that there's more experiments coming up here, because we always have room for more.
For Mike, NASA is testing a new way to transfer fuel by space robots called the Remote Robotic Oxidizer Transfer Test. The fuel is used in space is extremely corrosive, but if the testing is successful, what could it mean for technology in space and exploration?
Yeah, so again, that's another one of these new experiments that is going to be coming up here, I guess, later on. And so just like what Rick said, that's very exciting, because it's good to see those kind of activities happening. And this one in particular, I think it's going to be very useful for as we go beyond low Earth orbit and we start to do deeper exploration into the solar system, whether it be to the moon or asteroids or Mars. So I think those are critical technologies that need to be demonstrated, and I think it's going to be very exciting to see those results.
For Koichi, how do you feel about becoming the first Japanese commander of the space station?
It is a great honor for me to serve as an ISS commander, and it is a challenge. And but I'm humbled to take up this challenge, and having this responsibility is a welcome challenge for me to serve my duties on board the space station while keeping in mind the best interests of safe and efficient operation of the space station. It's really great to be part of the wonderful team.
And Rick, what role might the ISS play in the United States' plan to possibly return to the moon and then move on to Mars?
Could you repeat the question, please?
What role might the ISS play in the United States' plan to possibly return to the moon and then move to Mars?
Oh, well, yeah, the ISS is a big part of that. It's like the first step in returning to, going to beyond low Earth orbit, returning to the moon or going to Mars. We're developing a lot of the technologies. We're developing a lot of the procedures right here. We could test out new ideas up here. We're learning how to recycle water, recycle air. We're learning all the things that it's going to take to go beyond low Earth orbit. So all the things that we are doing here are the first step and a big part of moving on beyond low Earth orbit, going to the moon and asteroids and Mars and other things like that.
Mike, can you tell us about your college experience?
Well, it seems like a very long time ago. Yeah, it was a wonderful experience, and it's a big part of why I have the opportunity to be with NASA and to be up here today and working with such a great team. You know, when I went to college at the University of Illinois and then on to Stanford in aerospace engineering, I had no idea that I was going to get this opportunity. It was certainly something I dreamed about, but at the same time, it was something I just had a great time with studying there. I had the opportunity to play football in college. I was part of the ROTC program and the Pi Kappa Alpha fraternity. So the college experience was just absolutely fantastic, and best of all, that's where I met my wife.
Koichi, what is the training process like to prepare for a mission to the space station?
Yeah, the training flow is for about 2.5 years after assigned to a space flight on board the space station. We have training in Houston, in Moscow, Cologne, Germany, Montreal, Canada, and in Tsukuba in Japan. It's a very extensive training. And we learn about the space systems operation, experiments, payloads, spacewalks, robotics operation, etc. And it is very exciting to learn from the experts of the subject matter in different countries.
Rick, besides friends and family, what is one thing you miss from Earth?
No, that's easy. Food. You know, all our favorite foods. We had a wide selection of food up here, and it's actually pretty good. But obviously, our favorite foods, you know, it's been a while since we've had them, and I look forward to having them again once I land here in a couple of months.
Mike, can you describe the experience of your first launch into space?
Yeah, it was a bit surreal. As Koichi talked about, you spend 2.5 years preparing for that moment, and at some point you kind of wonder if it's ever really going to happen, and you don't really believe it's going to happen until you actually start to lift off, because you just think, oh man, you might get hurt, you might get sick, or something else could happen that would pull you out of that. So first of all, there's a bit of a sense of relief that, hey, I'm actually launching. At the same time, there's this jumble of emotions that are going through you. You know, for me, it was my first launch, so you're very nervous, you're very excited, but you're also very focused, because you've trained a long time for this, you know the procedures, so you're just basically walking through the checklist and making sure everything's performing the way it's supposed to, and really the training kicks in at that point, and it's a great ride.
Koichi, what is the best piece of advice you've received?
Okay, from my previous crew commanders of my previous space missions, I learned that keeping a good communication with the ground team is a key to a successful mission. Space station is such a complicated technological asset, and we have outstanding ground support team in the different control centers throughout the world. And we greatly depend on the success on the mission control centers. So keeping good communication is really a key. That's what I learned.
And for Mike, final question. The sun rises and sets every 90 minutes. What's it like to see that, and how do you get some shut-eye?
I'm sorry, we didn't catch the question. Can you repeat it one more time?
Sure. The sun sets and rises every 90 minutes. How does it to experience that, and how do you get some sleep?
Okay, yeah, that is, it's actually pretty neat to have that many sunrises and sunsets. And to be honest, we don't really notice it too much, though, when we're working inside the space station, because we really don't have a lot of windows that are looking out on the Earth and seeing the night and day cycles. And so really, in terms of impacting our sleep, it's not too bad. When it's time to go to bed, we simply just turn off the lights, and as far as we know, it's nighttime, just like down on Earth. But getting to see that many sunrises and sunsets, in fact, when the sun rises, you start out with just this little line of blue on the horizon or the limb of the Earth, and then you get a little bit of orange, and then this brilliant sun just blinds you, and getting to see that 16 times a day is fantastic.
All right, thank you very much. We want to thank Mike, Rick, and Koichi for talking with us today.
Thank you very much. We appreciate it.
And joining us now back here on Earth is Dr. John Halferty of Electrical and Computer Engineering here at Temple. John works to integrate NASA-related fields into the undergraduate program.
Thank you very much. It's a pleasure.
Thanks for joining us, Dr. Halferty.
Pleasure.
So you're a baby boomer that grew up watching some of the first expeditions into space. What was it like for you to see people living in orbit for extended periods?
Breathtaking, to say the least. It's my first experience with, really, I wouldn't be here if it wasn't for some of the activities that NASA does. My first experience was actually with the Voyager probe. I was a high school student as a senior, and they shot back some images of the Voyager probe that actually went out to Saturn and Jupiter. And I went back to my high school teacher the next day, my physics teacher, and I said, I'm going to work someday where they make that stuff. And it was a dream come true. So.
All right, and the work that you do is literally rocket science. What is the importance of the work that scientists do here on the ground and for the ongoing expedition on ISS?
Oh, there's no question. If you look at the work that we do on the ISS and on the ground, just think of what's going on now in the environment with the polar vortex that we're getting now. We're seeing systems, environmental systems that we have not experienced in our lifetime. So these are changes that are going on the Earth that you're actually witnessing from space also. So there's quite a lot of activity that's going on that we need to figure out why what's happening there. So.
Do you expect any of your NASA-funded robotics projects to make up the trip into orbit?
We're hoping to. They have just launched on the space station this week on Expedition 38 what are called CubeSats. These are very small little satellites that students make at universities all around the country. And we're doing right now suborbital launches out of Wallops Island to just below orbit. And eventually our goal here at Temple is to make some CubeSats that will actually get launched on the ISS in the future.
All right, and for you and your students, what is the biggest accomplishment you guys have had in the field so far?
I'm looking at it right now. I can't believe we're actually the accomplishments are actually multifold, I would say. In engineering, you do a lot of textbook work and you do some hands-on work, but this is all the work that's done in our student space lab here is outside of the classroom. So the students are actually doing NASA-related projects that are not related to coursework, but this is really following their dreams of doing, this excellent cutting-edge space technology. So.
And what are the goals of these programs going forward?
Well, the goals are actually, you have to ask yourself, is the world getting more or less technologically advanced? And I think the answer to that is yes, it is getting more technologically advanced. And that's where our goal is, to keep students on the cutting edge of that technology. And it's great to see that it's happening here at Temple Made, right here at Temple University. So.
Thank you for joining us, Dr. Halferty. That's all the time we have here for TUTV Space Station Live.
We want to thank Dr. Halferty along with the engineering students for stopping by to ask questions, and of course we want to thank everyone from NASA for giving us an inside look at Expedition 38. For Nick Lucier, I'm Karina Cheung. Have a great day.